Hello everyone. For everyone that's watching us from in YouTube, our learning objective for chapter 17 is how we create factor variables, how and explore the general social survey dataset uh, with um, uh, with the factors applying it when you apply a factor for on it. Then we will discover or go through the reordering of factors, factor levels. I think levels is some kind of attributes that inside factors, and we can control their order with some kind of functions. So we'll discuss the ordering stuff, the ordering functions, all the ordering functions. Then we will discuss or discover some functions that like modify factor levels, like factor collapse, factor lump, and factor recode. Um, so let's go into the first. So factor are used for categorical variables. So inside R, we representing like categorical variables, not like any other programming languages. It's like there is a specific type for categorical variables uh, that we call factor in like a data type that store categorical variables with some kind of attribute on top of it. So variables that have a fixed and known set of possible values, those what we call factors. And they also are useful when you want to display character vectors in a non-alphabetical order. So again, we just like import or use the library tidyverse. I think all the books that we would use we mainly use the tidyverse, so it's normal. Um, yeah, so we will talk about the factor basics. So imagine we have a variable that record months, and we just have like a list, a combined list for with the first three alphabet for every month. And here is an example like December, April, January, and March. And we using a string to record this variable has two problems. There are only 12 possible months, and there's nothing saving you from typos. And also we can sort them in a useful way. Um, so when we and here we could fix this with factors. We could fix both this problem with factors with a factor. To create a factor, you must start by creating a list of valid variables. Um, and yeah, like we defining the list, the levels in a combined way, like this. We just like defining a list of months, first three alphabet for a month, and um yeah, and after that it's like this containing the months every month, and now we can create the factor with the factor function. The factor function is used to as a factory function, something like that, and we pass through it the levels variable where we define the levels for every factor. And I think levels is like how we should order them uh, in a hierarchical way. So at least this is how I think about it. So the y1 here is basically just like we converting the x1 variable into a factor. We transform it to a factor, and we give it a levels that we should order according to them. So if we say y1 in R, the command line will output um, like this stuff. So the variable itself is this subset of variables, and the levels are all the levels that we already defined here. So, but the difference here is when we use the sort function, when we want to sort them out according to a specific like alphabetical order, we use a sort function, and internally like it designed internally using, I think, what's called the object orientation stuff, I think, internally. So they defined the sorting, how they should sort the factors as a class. Okay, so when you're using sort, they sorted them out. The subset has been sorted, and they show the levels also as the same order as as we defined them before. So any values not in the levels will be silently converted to an A. So any variables that is like odd doesn't exist in the levels list, like the defined list of levels, it will factor will like assign an NA and replace this variable with NA. Sometimes we would prefer that the order of levels matches the order of the first appearance in the data. So we prefer that a specific order when we defining the variable, and we can do that when we creating the factor by setting levels to unique. We use here the unique function to just get the unique categories or categorical uh, data from the variable itself, and then we order them in after we get the unique categories. So here, um, so it's like we fact in order. So here, how he did this, like I think he like described the levels, how he did, like the levels is cutting down to, okay, so
Sorry. I think if I get it, like you explained the levels. So like the levels is just like the reference point, like the reference where the values or the strings that you reference to, sort of.
yeah.
Yeah. So like with the unique function, so it's just like the unique function. He assigns the level to the unique function, which just keeps the value of x1.
Oh yeah.
Previously he was assigning the levels to the 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 the,
Yeah,
the,
the X1
the
here.
level we
Yeah.
created at the beginning.
Yeah.
But now he just assigned it to the unique function of x1.
Yeah, but I don't see the benefit from here, because you're just defining the categorical data
Yeah,
as the same as the variable. So it's not useful. I don't know why it's, I think he comparing the using unique versus using the piping with fact in order, which is the same. So yeah, it's just comparing the same output, but in different way.
yeah.
Yeah. So yeah, I think there's it's just comparison. It doesn't intend to explain anything else. Um, so level F2. So we can also create a factor when reading your data with read R with column factor. So this is a way to create like converting a factor internally when using read CSV, using this call factor when we with assigning it to the month, and the month itself it's a column type, one of the columns. So yeah, this is how we define, we read a factor or converting a factor on the fly when you're reading with read CSV file, read CSV function, sorry. So let's go to the next slide. So this is the GSS categorical, which is like, I think it's a data set about material, race. So yeah, some like a data set that we should discover to with a lot of categorical variables, which is the factors. Here is a factor, and like the material is a factor, and race and race income the same, and party ID, religion. I don't know what this mean to be, but and denom.
So like the
So
religion,
what?
religion, like the religion.
Religion?
Yeah.
I don't see the full data, but it's, yeah, it may be
Yeah, it's
religion.
religion. I've seen it. It's religion.
Okay, so it's religion. Nice. So when factors are stored in a tuple, we can't see their level so easily. One way to view them in with count. Yeah, so it's, you could like use a count for to see the level of a factor, but at the same time we are aggregating the variables to see like sum it, and like have the sum of each one, and see this categorical the levels itself with the sum. So here as we see here, like other is 1959. So yeah, this is the general social survey. Let's go to the next slide. Here we give a religion summary, something like that, from the categorical data set that we are exploring. We group by religion, then summarize using the age and the TV hours that spent. Um, like the mean, we getting the mean of the age and the mean of the TV hours with NA. We remove NA, which is and here in our, like we see we get the number of uh, of of the summarized way. So it's like aggregating with getting the count. It's like same as the count, but when you use summarize, we use n to like simulate the count function. So yeah, this, and then we plotting the religion summary with aesthetics, which in the x-axis TV hours, and religion in the y-axis, and we doing a scatter plot, which we seeing here, like hedonism, Buddhism, and other stuff. You don't see Islam, which is interesting. So yeah, uh,
Yeah, you
it's
have like
hard.
Muslim.
Oh yeah,
Yeah,
Muslim.
yeah,
Muslim slash Islam, but
yeah.
Muslim is not Islam, so I don't know why
But that's
it's.
how Americans pronounce it, you know.
Oh, so is the American are pronouncing Muslim,
Yeah,
not
yeah, they say
Islam?
Muslim.
Also, they didn't know the difference between a Muslim, which is one the fellow Islam, and the religion itself, which is Islam. Okay, very interesting. So it is hard to read this plot because there is no overall pattern. Yeah, there's just a point scattered in every area, so we don't see a pattern. We can improve it by reordering the levels of religion using factory order, and factor order also takes three argument: the factor and the numeric vector that you want to use to reorder the levels, and optionally a function that used if there is are multiple values of x, which is a numeric vector. So if there is a multiple values of the numeric vector that we already assigned, we use this function to apply on, like, it's like some kind of aggregation. It's the same as aggregation function, but it's optional. You can do it. The default is mean. Yeah, you could do the the default is median, and you could do the mean. You could do the standard deviation, I think. So yeah, this is, and you see here is a pattern now when we use the reorder, and we order based on the TV hours, I think. Um, yeah, the number of TV hours. So it's like is getting to the Native American, which is, I don't think Native American is a religion, but I don't know why it's here. But I think this need to be like cleaned more, because don't know is not a religion. Native American not a religion. Um, but yeah, just the Native Americans are, which is it's maybe that the ones that don't have a religion, they say Native American. So a lot of some of analysis will be useful here. So changing the levels of a factor, we use yeah, the same thing. I think we group by the income, but here, yeah, this is the one that he talking about changing the level with re-level, which is a function that really take just the column name, which is income, and the level that really want to replace or reorder. And yeah, I think here, where is it come from? Not applicable. Yeah, this one. This is the one that really want to add. I think it's adding, right? Changing the level of a factor. I think it's adding like a category, right?
Like adding, you mean?
Yeah, like adding a categorical variable on top of this column, because it's called the re-level. So or it's like
I think
changing
it's just changing the order of the
yeah,
levels.
yeah, it may, yeah, I think that also. So it's just changing the order, but um
It's
it's
starting from making the not applicable, starting from the not applicable, going the reverse order, something like this.
oh yeah, 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 something like that. Yeah, yeah, it seems that's the right answer. So here he what he's doing here by age, so it's he filtering is in A, so it's like not in A, and count the age and material, and group by in age. He gives the proportion. Okay, so okay, so yeah, this is not related to the order, but he now here he's he using the reorder again to change the order of the levels um, based on, like, I think the proportion. Yeah, he's changing the order based on the proportion. Um, so but yeah, it's like the proportion here is like 1 and getting down, which is never married. Yeah. So yeah, just changing the order of a power plot is in decreasing frequency with yeah, this is another one. We decrease with decreasing frequency with the fact infrequent function, and in increasing frequency with fact I think reverse or reverse frequency, something like that. Um, so it's like just doing the reverse, the infrequence and reverse infrequence, just changing the orders in different ways. Let's see the next slide. So here he talked about the modifying the levels. how we could like modify the levels on with at the same time when we use a mutate function. So here we use a recode with the party ID, which is the one that we want to get like define a categories for it, which because it's not categorical variables. Now we want to transfer it to a categorical one with like a definition of every category. So here Republican and strong, strong Republican, Republican weak, not strong Republican, something like that. So we just defining the factories on the fly with the function, the factor with the fly on the function to transfer like a non-factor, right? It's yeah, a non-factor variable to a factor, just defining it in on the fly with a function. So to combine groups,
So, sorry, I think if I get it right, he's just trying to like just adjust the naming. I think this they are not named. The name
so
is not.
it's not like defining.
Yeah, here he's just trying to rename it, sort of giving it a better name, sort of.
Let's see here. Yeah, it's already fact. Yeah, yeah.
Yeah,
Yeah,
it's,
it's
yeah,
my mistake. Yeah, yeah. It's it just redefined the name.
yeah,
So
yeah. That's
recode,
yeah,
yeah, recode is just giving it another name, just
yeah.
renaming the factor on the fly with a function.
So from the
Um,
left, we replace the right one with the left names, sort
yeah,
of.
just this is the old naming, and
That's going to be the new.
this is
So
a new naming.
yeah,
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 so I don't know why it it's not like they specify because the equal sign is like getting this
yeah,
instead
yeah.
of
So the left
replace.
replaces the right, basically.
Yeah,
Mm.
so it's like a syntax. I think it's a syntax.
Yeah,
Uh, awesome. So um, yeah, to combine groups, we can assign multiple old levels to the same new level, and like you can assign. You're doing the same here. You just um, we can assign multiple old levels to the same new level. Yeah, this is you're talking about this other stuff.
yeah,
Yeah, the same. Yeah, same multiple olds with the same new. This is the new one, so we assigning the same to uh, multiple multiple values just to
yeah,
aggregate stuff that we don't need, I think, in
yeah.
our
Sure. Yeah,
analysis. So we don't care about no answer, don't know, other party. So we just name it as others, and when we count them, so we see here that they aggregate all the threes in this other category. Yeah, just to like eliminate some of unuseful categories or values in our categorical variable. So if we want to collapse a lot of levels, we use the fact collapse. Is a useful variant of fact recode. For each new variable, you can provide a vector of old level. So yeah, here we are defining a vector instead of a string in the old recode. So yeah, it's just like a level. We adding a level inside a level, something like that. So other here we defining a list, and rip here is we defining another list. So we just like minimizing the categories with lists, just a list that depend. And here we could use this in like summarizing more. Uh, the like here we are we are grouping the independent, and here we grouping the demographic or Democrat variables, all the Democrat variables, and here all the independent variables, and here all the Republican, and anything else is in other. So we just group. We use the fact collapse to group with using lists, group levels using lists. Okay. And here when you use count, we get the new counting. What else? So yeah, lump low frequency. So this I don't know what this is doing. So let's see. Is giving the religion a new factorial low frequency. So I think if it yeah, I think we know we need to see the religion thing, but since we have like we have a graph here to religion. Where is it? It's in the top. Let's see. Yeah, this one. This is about the religions. We're talking about the
Yeah, yeah. I think the
Protestant. Yeah,
lump. I think the lump just tries to maybe some of the less significant values that we are not interested in. We could just group them together, something like this, using the lump function.
yeah,
Um,
and
is
hello.
it?
Yeah, yeah. Hi,
I think is it the same as collapse, right? Is
The
it?
yeah,
same as
it's very similar to collapse. Yeah.
I think collapse is just defining like a list to a level, like grouping levels to each other, right? Grouping levels in other level, like other categories. Like we are defining categories with lists of other categories that exist in a categorical variable. But here it gets the list, the low frequency. I think yeah, they get all the low frequencies that doesn't appear too much in the column, and they assign it to other. This is what
Yeah.
I
Yeah.
get from
Yeah.
it. And the most one that's really frequent, which is Protestant, I think Protestant, yeah, Protestant. Uh, it leave it outside. So basically getting the most frequent, like the mode function doing right. I think the mode getting this, like getting the most common values in a category, like. So yeah, I think that's what low frequency do. But he said here, read the documentation to learn about the minimum, the lump minimum and the lump proportion, which are useful in other cases. Okay. So what else we have? So just some to read. Yeah, I think we are finished. But mainly we are using this the factors to uh, have some kind of level, another level of analysis to categorical variables that you don't see in other languages like Python, for example. We don't have like this kind of thing, but we can do it, but we don't have a name for it, like in the language itself, uh, already defined in the language to help us do analysis on categories. So this one of very useful. So and I will use it for sure in my next analysis because it's very interesting. Yeah, and anyone have any question before we wrap it up?
No, thanks a lot.
Thanks a lot.
Thanks.
Cool. I think we have the next chapter is date and time. And nobody sign up. And
Yeah, I think I'll give it a shot. I'll just try to use the sign up as a commitment device. let's see what happens. But maybe something you could be on standby if I happen to. But I'll try to.
Yeah, and if nobody is like signed up for it, we can like go through it together. No, like don't have
Yeah.
like to specific one to have
Yeah.
like, but
Okay.
because the order we just sign it for ordering and making things like organized, but we can go through it together. No problem.
Yeah. So
I'll try to prepare for it in any case.
yeah. So basically, next week, at this time, I will travel. I will be in Kigali, Rwanda. So yeah, I will try
Okay, so
to.
we'll be like just two of us.
Yeah, and yeah, I think I will be able to join. I don't know how it will be, but just to let you know, if I don't manage, I will not I'll be in Kigali that time.
Safe journey.
Yeah, sure. No problem.
Okay.
Yeah, safe
Alright.
journey.
Thank
Yeah,
you.
anyways, we'll
Yeah.
try to make it. Yeah.
Okay, so see you next week, inshallah.
Yeah. See you.
Inshallah.
Thanks.
Yeah.
See you,
Bye.
brother. Bye.